Welcome to Ask and Learn.
Problem 23.60. So they're told a story about an explosion that happened at a biscuit factory in the 1970s. And in general, there are problems that have to be considered with any sort of powder or grain handling. Because if static charges build up, then you can have explosions and fires and things. And that's quite dangerous. In addition to also, secondary concern is the economic sort of losses from, whatever it is that you're handling, exploding or burning. So here we're considering chocolate crumbs. They have negative charge and are being blown through a pipe with a radius of 5 centimeters with some charge density. First, we want to find out what the electric field is. We want to say whether it increases or decreases with radius, whether it's directed inward or outward radially, and then what the maximum electric field is given this charge density and whether that's enough to cause a spark. We're told the condition for that in the statement of the problem, and we'll look at that when we get there. So, just using Gauss's law, the volume that we're going to be enclosing is L pi r squared for, some L. What we're going to do is we're going to have E is going to be Q enclosed divided by epsilon naught times the area of the cylinder. This is our volume, so we're going to have rho times L pi r squared divided by epsilon naught times 2 pi r L. And so we get rho r over 2 epsilon naught which we've also seen before in the context of cylinders of charge. If we're finding the electric field inside of the cylinder. This is linear in R, so it increases with increasing radius. The powder has a negative charge. This is just the magnitude of the field. But it has a negative charge, and so the field is directed inward. So for part D, now this is the charge density, and we want to say what's the maximum value E takes in the pipe and where that occurs. So from this we can see that the maximum value is just going to be at little r equals big R. So that's where it will occur. So this will be rho times big R divided by 2 epsilon naught. So this is 3.1 million newtons per coulomb. And now we want to ask if this, if sparking will occur, and we're told that the statement of the problem that with a field of 3 times 10 to the 6th newtons per coulomb, there will be sparking. This is bigger than that at the outside diameter of the pipe. So, yes, sparking can occur. And so we can see that there's a potentially dangerous situation going on here.